All right, so again, section 6.3, multiplying higher degree radicals with variables sometimes. You can see the first two don't have any, but they are supposed to have some variables at times. Now, I want you guys to notice when we're doing these things, when we multiply radicals, and let me just kind of show you just a little tiny bit of notes that you do need for this. When you get radical x times radical y, notice they aren't the same radicals, right? One is an x, one is a y. All you do is multiply them inside, okay? That's all you do. You just put them together, okay? And then from there you simplify as much as you can. All right? Like this is the whole lesson right here in that little statement right there. So, for example, if you had radical 2 times radical 3 times radical 6, all you have to do is multiply it all. So it's going to be square root of, I'm just going to show the step, 2 times 3 times 6, which is the square root of 36, right? Because 2 times 3 is 6, and 6 times 6 is 36, and the square root of 36 is 6. So that's how these problems are done. Now, sometimes you'll get variables, and you can combine the variables and stuff like that too. But it's basically just multiply things out, okay? So let me show you your homework. You guys have 16 problems, okay, just so you know. So let's start off with number 2 here, okay? So we get negative radical 3 times radical 6. Okay, negative radical 3 times radical 6. So I'm just going to multiply these things. Well, first off, I'm going to look and see if they have square roots, but square root of 3 doesn't exist, the square root of 6 doesn't exist, so I'm just going to multiply them. That's the square root of 18. Now, can I break up 18 into two numbers, one of which has a square root? Like, what two numbers can I use for 18? 9 and 2. 9 has a nice square root, so I can take it out. That's a negative. When I take out the 9, it's going to become a 3, okay? So that's going to be a 3 radical 2. And that's my answer. Negative 3 radical 2. So after you multiply, you're going to want to try to simplify it. Okay? Now, you can distribute with these things. I mean, look at question number 4. You are able to just distribute in. Okay? So let's go ahead and do that. So negative 3 radical 6 times 3 plus radical 3. Now, if it's a normal number, you multiply it in the front. If it's a square root, you multiply it inside the square roots, okay? So when I multiply negative 3 radical 6 times 3, I'm going to get negative 9 radical 6. Because the whole number multiplies the whole number. So negative 3 times 3 is negative 9. And then I'm going to multiply negative 3 radical 6 times times a radical 3. In that case, the radicals multiply. So it's going to be negative 3 radical 18, right? 6 times 3 on the inside of the radicals. Now, can we break up 6 into two numbers that have a nice square root? No, right? It's just 2 times 3. Those don't have square roots. 1 and 6 don't have square roots. And 18 we can, though. So that's negative 9 square root of 6 minus 3 times 9 times 2. We just did that. This is going to go out, and it's going to make us multiply times 3, okay? We're going to multiply times 3 when it goes out. So negative 9 radical 6 minus 9 radical 2. It's right here. Part C. By the way, on the other problem, I forgot to mark it, but I think that answer was C as well. Yeah. Are we okay with this? Just multiplying, simplifying, that's pretty much it. That's all you have to do. Now, sometimes you have to multiply by foiling, right? A distribution. So we're going to take this kind of slowly. Let me rewrite this. This is radical 2 plus 5 radical 5. And radical 2 plus 3 radical 5. All right, so FOIL this thing or distribute. Radical 2 times radical 2 is radical 4. Okay, or square root of 4. Radical 2 times 3 radical 5 is positive 3 radical 10. Okay, because 5 times 2 on the in the square root, 2 times 5 is 10. On the outside, you have that 3, so you're just going to multiply the 3 in the front. Now, 5 radical 5 times radical 2. So the 5 is going to stay on the outside because there's no whole numbers to multiply. But the square root part, 5 times 2, is 10. And then the last part, 5 radical 5 times 3 radical 5. Well, 5 times 3 is 15. And the square root of 5 times 5 is 25. So now let's start simplifying. What's the square root of 4? 2. Now you notice these are like radicals. Okay, so 3 plus 5 is 8, so I'm going to put 8 radical 10. And then I have 15 times the square root of 25. What's the square root of 25? 5. So let me just simplify that. 15 times 5. All right. Well, the 2 I can't do anything with. Can I break up the square root of 10 into two numbers that have a nice square root, or maybe one number that has a nice square root? It's 1 and 10. Those don't work. Well, 4 doesn't go into 10. 2 and 5 does, but those don't have square roots, right? So I can't do anything there. 15 times 5, well, let's see. 15 times 2 is 30, times 4 is 60, so it'll be 75. So 2 plus 8 radical 10 plus 75. And then 75 plus 2, that's 77. Plus 8 radical 10. And that's right there. Okay? So you can combine normal numbers. You can combine like radicals. Okay? You can't combine radicals with just numbers. They have to have the same roots there, right? So that's how you would do number 6. Notice I'm not rushing through this stuff. I'm taking my time, making sure that I'm thinking about everything that's being given to me. Okay? And then I'm able to find out, what exactly my answer is. Okay? Any questions so far? Let me kind of go back. Number 2. Okay, that was pretty quick. Number 4. Or maybe number 6. Number 4, what's up with number 4? You didn't understand how it worked out? So we're just distributing, right? So we start off with negative 3 radical 6 times this, right? So we want to just distribute it to each one. Now, since this is a whole number, I get to multiply it with this whole number here. So 3 times 3 is 9, right? So negative 9. Radical 6 just kind of goes along for the ride. And then I got to multiply negative 3 radical 6 times a radical 3. Well, the two radicals will multiply. Okay? So 6 times 3 is 18, and the negative 3 is just going to come along for the ride. So it's going to be negative 3 radical 18. At that point, we said, can we simplify the radicals? Now, radical 6 cannot be, but radical 18 can be rewritten as 9 times 2. Okay? Once we did that, we said, okay, the square root of 9 is 3. So when we take it out, you're going to multiply by 3, right? Because that's what the square root of 9 is. It's a 3. So 3 times 3 is 9. So that's why that came out right here on the answer, right? 9 radical 2. The 2 is left over. Does that make sense? Or was it just that you had to write it out? Oh, okay. And then what about 6? Anybody have questions on 6? And just take your time with it, right? Don't rush it. So the rest of the problems, I think, are going to have variables. So let's take a look at number 8. So when you're doing these things, make sure that you guys are, I mean, if you want to simplify first, you can. I usually tell people just multiply and then simplify later. But sometimes it's good to simplify first because it makes the numbers smaller. Okay? So let me show you what I'm talking about. 12x cubed times 2 square root of 6x. Okay? So that's what I have. Now, since I have variables, I'm going to multiply things out, and I'm going to try my best to simplify this as much as possible. So if I multiply these together, notice this is a whole number. This one doesn't have one. Well, it is. It's a 1 there, right? So 2 times 1 is 2, so I'm just going to put 2. And then the square roots, I'm going to multiply them out. Okay? 12 times 6 is 72. Okay, and then x cubed times x is x to the 4th. Okay? So, all right. My index on a square root is a 2. You see that x to the 4th? I'm going to have to write it as x squared, okay? But that's going to be my next step. Before I do that, though, I got to ask myself, is there a way that I can break up 72 so that one of the numbers is a nice square root? So here, let's do our multiplications for this. 1 times 72 is 72, right? But none of those are going to work. 2 times 36, will that work? Are one of those two numbers a nice square root? 36 is, right? So here we go. 2, index of 2, 36 times 2 times x squared. Now remember, the 36 is going to go. Okay, it's going to come out. It's going to become times 6, okay, because that's the square root of 36. It multiplies times 6. And then my index matches these powers. So I'm going to take out two x's. This x and that x. So what do I get? Well, let's see. 2 times 6 times x. What's left on the inside? Just a 2, right? That's all there is. Everything else left. 2 times 6 is 12. X times x is x squared. Radical 2. So here is your answer. And there you go. So you're going to want to multiply everything out, and then you got to start breaking it down, just like we've been doing, but now we have variables, right? But you got to start breaking it down little by little to reduce it as much as possible. And yes, that's not always easy. You might say, wow, 72, how'd you know it was 36? Guys, all I did was ask myself, what divides it, right? So like I could have kept going. I could have said, well, 3 goes into 72 24 times. But I would say, well, 3 and 24, they don't have nice square roots. Does 4 go into 72? I think it does. 4 goes into it 18 times. Well, actually, 4 has a nice square root, right? What else? 5 doesn't. 6 goes into it 12 times. None of those have nice square roots. And then 8 and 9. 9 has a nice square root, right? But remember what I told you guys. The trick is to pick the biggest number with the square root, which would be 36, right? So you can write down all your factors and then pick the right one. And remember what I told you guys, if you're ever having trouble figuring out the factors to a number, do a Google search. Just type in factors of and then your number, and it'll list them all for you, right? And then you can say, okay, which one's the best answer? Okay? So these were all just, those were all just products, okay? This 1 times 72, 2 times 36, like these are all multiplications that I'm just trying to figure out, okay? Any questions on 8? All right, so look at number 10. It's starting to get a little bit on the bigger side with numbers, okay? But we can still work this out. So square root of 15v squared times 3 square root of 25v squared. Now sometimes people tell me, Mr. V, radical 25v squared, can't we simplify that right away? Yes, you could. If you want to, you can. Right? This right here is just 5v. Okay, now I'm not going to do that just for the sake of trying to make this as simple as possible, even though the numbers get a little bit big. But I'm not gonna do that right now. But you could do that. So let me show you how you would do it at first. So you're going to multiply. Okay, 3 times 1. So 3 times 1, that's 3. And then inside of the square root, 15 times 25. So I know 4 times 25 is 100. 8 times 25 is 200. 12 times 25 is 300. So it's 375. V to the 4th. Okay? Now, I'm going to write down factors of 375. Okay? All right, so 375 is 15 times 25, and 25 has a nice square root, so this is going to be 3 square root of 15 times 25. And what's my index on the square root? 2. So that means I get to write this as v squared. Now notice my index matches these powers, and I know that 25 has a nice square root. It's going to go out and become a what? A 5, okay? So my answer is, well, close, 3 times 5. Actually, let me put these other little arrows here. So 3 times 5 times v square root of whatever's left over, which is just a 15. Okay, so that's 15v squared. Radical 15. I don't know why, but all these answers seem to be C right now. I know they'll mix up and stuff later, but are we okay with this one? I mean, I know the numbers got large, but like I said, you guys have options. You can look online, have it find you your factors. Okay? Or you could just do it yourself, right? Just think, okay, 375, 75 is divisible by 25, so 25 is a good number to pick, right? But it just depends on what you feel comfortable with. All right? So let me just, let me check these other two. These are cubes, so that's good, cubed, cubed. So let's do some of these cubed ones. We'll do number 12. So cubed root of negative 10 n to the fourth times cubed root of 24n cubed. So cubed root of negative 10 n to the fourth and 24n cubed. Okay, first thing you guys should probably do is, you see how there's a negative in one of the cubed roots? Take it out. So I'm gonna make it negative cubed root of 10n to the fourth, okay, times cubed root of 24n to the third. Okay, now I'm going to multiply. So when I multiply, I get negative cubed root of 10 times 24 is 240 n to the seventh. Okay, so now I got to think of factors of 240 that have a nice cubed root. So like I said, let's check out Google, right? So let's find factors of 240. All right, so what do they tell me here? So let's see. Factors of 240. We start with the big ones. Let me get rid of this. Sorry about the ads there. I know 120 doesn't have a cubed root. 80 doesn't have one. 64 does, but it's not there. What's the best cubed root that you guys can see? So remember, you're supposed to have that list, right? So 64 was 1, 27 was 1. After 27 was 8. 8. Okay? So it's 8. That's the best cubed root, or the best number I can use for a cubed root. So 8 times what? That would be 8 times 30. Okay? 8 times 30 is 240. So let me write it out. Negative cubed root 8 times 30 n to the third, n to the third, n. Remember, you got to break up your n values so that they match the index, right? So this matches here, here, and there. And then my 30, I'm sorry, not 30, my 8 is going to go out. So the 8 will become a 2, and this n will come out, and this n will come out. So this will be negative 2n squared, because there's two n's. So n squared, cubed root of 30n. That's right there. D. Are you guys good, or you want me to do another one for you? You let me know. It is your homework, so. Would you like to see another one? No comments? Yes? Okay, I see one. So let's do 14. After that, I'll stop, okay? All right, so for number 14, cubed root of 50 n to the fourth times cubed root of 3n cubed. Okay. So let's multiply this out. Cubed root of 50 times 3 is 150. N to the fourth times n to the third is n to the seventh. So now I got to think, okay, 150. What are factors of 150 that I can take as a cubed root? So again, I'm just going to go really quick and type in factors of 150. Okay. And probably going to get an add again. All right. Are there any numbers there that have nice cubed roots? Remember, the cubed roots, we had a cube root of 1 that exists. Cube root of 8. Do you see an 8 there? No. Cube root of 27? No, right? We don't see a 27. A cube root of 64 was the next one. And the next one was a 125. And the one after that was a 343. Do you see any of those? No. So that means 150 cannot be broken down into something that has a nice prime factor. Okay? But the letters can. N to the third, n to the third, n. So those match. They'll come out. So that'll be n squared cubed root of 150n. That's B. Okay? So I'm going to go ahead and stop there.